Hello everybody, today we will be going over a geometry problem with pyramids at the IB Math AISL level. So we have the following diagram. ABCD is the square base of a right pyramid with vertex E. And so when they talk about a square base, that's just telling me that, hey, this guy at the bottom is a square. ¿Cierto? That means that this guy is equal to this guy, is equal to this guy, is equal to this guy. See, that's the information that it's giving us. And right pyramid, the word right, it says a couple of things, but the most important one really is that this height here is completely straight. See, it is like a vertical height. It's not slanted. It's completely vertical. That it? All right. The center of the base is O. That is this guy here. Cierto, that point that's right there. And the diagonal of the base, AC, which I will draw in red, is 6 centimeters long. Cierto? So that guy there is 6 centimeters. And the sloping edges, which I will draw in, let's say, black, are 9 centimeters long. Cierto? So that is this line here, this line here, this line here, this line here. All of those guys are 9 centimeters long. Okay, that is information that is given to us, and we need to write down the length of AO for part A. Cierto? So I said that the guy in red was 6 centimeters. Cierto? So let me draw that out for a second. Here we have CA. Right here in the middle we have O. And this whole thing, cierto, is 6 centimeters. Cierto? That means that AO, which is right down the middle, cierto, is going to be half of my total, which is 6. And so AO has to be 3 centimeters, which means that the other side is also 3 centimeters. See? Awesome. The reason I can do that is because I know that it has a square base, cierto? So at the bottom, which is a square, the diagonals that cut through it, cierto? Right at the middle, these are equal. See? That is why I can assume that or like work like that, cierto? Because it's a square. All right. So, yeah, that's the length of AO, 3 centimeters. Make sure that you put the units, and we move on. Part B, find the size of the angle that the sloping edge AE makes with the base of the pyramid. So the angle that it is trying to make us find is the sloping edge with the base, ¿cierto? So, the sloping edge with the base, which we drew in red. See? So this angle that I'm about to draw, or color in better said, with yellow, is what we're trying to find. See? This guy there, I'm going to put in red. Maybe it's not too clear. That's the angle we're trying to find for part B. See? Now, anytime you have a pyramid, a general rule of thumb is that you want to work with the triangle that gets formed by this. The height, a sloping edge, and the middle or the center of my base. See? That is a triangle that you usually end up working with, and I actually have on the right side. So on the right side, I'm going to draw that triangle. It looks something like this. See? So I have A, I have O, and I have E. A, O, E. See, that is the triangle that we are working with. So I'm going to go ahead and make a little bit of space here just to leave super clear what is going on. I'm going to erase this. That is a triangle that we have. See? What else do we know about it? We know that this is a right angle, ¿cierto? Because as I said earlier, right pyramid, this height is perfectly straight up. So I can say that this is a right angle. We are trying to find theta, ¿cierto? Which is the angle that we need to find for part B. We know that the sloping edge is 9. And that is all we know. See? So this is the information that is given to us. And with this, we need to find the angle theta. See? Now, there's a couple ways to find angle theta here. I think the most reliable way is using the sine rule. The sine rule works with pairs, right? And so I need to see which pairs I have or which pairs I can make, right? So I have this angle paired with that side, so that is one whole pair. I need to find theta that goes with this side, so we're missing a height and an angle, ¿cierto? I've said that for the sine rule, you need 3 out of the 4, ¿cierto? What do you mean by 3 out of the 4? You have A sine A, B sine B, right? Big letters are angles, remember. So I have one side, which was 9. We have one sine, which is 90. We are missing the height, and we are missing the theta. So in a right pyramid, you can usually find the height pretty easily, ¿cierto? So how can I find h from this pyramid here? Sorry, from this triangle here. Well, it's a right triangle, ¿cierto? And so with right triangles, you should always think of the tools you can use. You can use Pythagoras theorem, see? So h squared plus 3 squared equals 9 squared, okay? A squared plus b squared equals c squared. That's what I'm using, ¿cierto? The c will always be the long part, the hypotenuse, see? So that is like my compass here, the 9 goes alone, see? All right, h squared plus 9 equals 81. H squared, h squared equals 72. H is the square root of 72. Let us check with our trusty rusty calculator how much that is. All right, so boom, 8.485. 8.485. I'll put a couple more just in case. See? All right, that's my height. See? So now I can plug in that height over here, which we said was 8.48528. And now I only have one variable, ¿cierto? I just need to get theta. I need to get theta alone, and that will be the angle that I need for part B. So to solve from this step onward, I need to first cross multiply, ¿cierto? And so I end up with 9, right, times sine theta equals 8.48528 times sine 90. See? I need to keep getting theta alone, so I'm actually going to divide by 9 on both sides. I end up with sine theta all by itself. And here, actually, in order to get theta alone, I need to use this thing called sine inverse. See? And so this is how sine inverse works. I apply it to both sides, ¿cierto? So I have sine inverse of sine theta equals sine inverse of this whole thing, ¿cierto? This whole thing being that, right? So when I use sine inverse, what happens is that my sines cancel out. I end up with just theta, ¿cierto? So I end up with theta equals sine inverse, right, of this whole thing. That is how sine inverse works. See, it just gets rid of like the sine part of it, but you still need to apply to both sides, ¿cierto? So I'm going to do that. I end up with sine inverse of this whole thing, which is this times this divided by this. Ufa, 70.528. See? So theta is 70.528. Let's put a couple more just in case. 77. See? So that is for part B. Finally, we have hence or otherwise. Find the area of the triangle CAE. ¿Cierto? So CAE goes back to the bigger triangle. ¿Cierto? So how can I find the area of that triangle there? Again, there's a couple of ways. I think the simplest one is the following. Because it's a right triangle, right, you have the height, ¿cierto? We did find h. And so you can use the classic base times height divided by 2 for the area of this triangle. Since we're talking about CAE, notice that it's the big triangle, ¿cierto? It's not this one. This would be half the big triangle, which you can use actually, but the more direct way is to say, all right, so we said that the base was 6, ¿cierto? We found the height, which was 8.48. 8.48528. All of this divided by 2. See? So the triangle that I'm talking about, just to leave it mega clear, is CAE. We know that here is O, ¿cierto? We know that this is the height. This is all stuff we found earlier. We know that this whole thing is 6. We know that the height is, well, what I mentioned earlier. And well, yeah, there it is. Base times height divided by 2. Let's check what the calculator gives us. Base times height divided by 2, 25.455. 25.455. Let's put a couple more just in case. Centimeters squared. Do not forget the units. That is very important. All right, so that is part A, that is part B, that is part C. That is how you solve this problem. What I suggest is that whenever you have a right pyramid, careful with what they give you, ¿cierto? The fact that it's a square base is more useful than what you think, ¿cierto? And you usually get a right pyramid anyway, and that helps you get the height much faster. I suggest getting the height anyways, because for some part of A, B, or C, like, you're probably gonna need it, ¿cierto? And so divide those triangles in half, make life easier on yourself, find the right triangle, because right triangles are our best friends to work with, and your life is gonna be easier. So yeah, I hope it helped. I'll see you around and take it easy.